There's a reason why most applications today use Postgres as their main relational database. And it's not just because it is free and open source, although that is a major factor. It's because it is built to be highly optimized and performant and very efficient. And all that boils down to how processes are managed in Postgres and how memory and storage is managed. So let's take a look at that. Let's begin with processes, right? So you have an application, your app, that wants to connect to a Postgres database, right, to retrieve or write data. And that's it's going to be referred to as your client process. Okay. So the client process is any process created by an application that wants to access Postgres, right? It could be pgadmin, it could be your application, it could be your terminal, anything. Okay. The first process in Postgres, in the Postgres server that interacts with this client process is the postmaster, right? The postmaster process. So this postmaster process is what retrieves the requests. Okay. So you send the request to Postgres and it is first handled by the postmaster process, which basically does the authentication or dating and grants the either authenticates or denies access to the Postgres server. Also determines the level of permission it has. And the main thing that this Postgres master does for your client process is to create a backend process that runs the operations for this client process, right? So it creates a backend process. And this basically carries out all the operations for your clients, which could be your application. So it does the writes, the reads, and all of that for this process. So many clients can create many backend processes within Postgres if you have many applications or many connections. So for every connection, it creates the postmaster creates a backend process. Postmaster also creates a background process, which is not necessarily tied to any client process, but performs various operations for Postgres itself. So you have the background process here, still handled and created by postmaster, and this performs things like writes. Right, if you need to write, these are some background processes are like your writers, right? Your writers which writes data from your shared buffers to the disk. And we'll talk about shared buffers in a minute when we start to talk about the memory. So stay with me. It also has some checkpoint processes. Your while writers, write ahead log writers, right? Auto vacuum. So processes like this and some others are background processes that are also handled by the postmaster process, right? That handles all of this stuff. Okay. So now let's look at how things are handled in the memory. All right. So here's how things work in the memory, right? First, you agree with me that a database is basically supposed to be saving your data, which is your data file, right, to a disk, some volume of some sort. But how Postgres works is that before the data is saved into the disk, it first keeps the data within a buffer, within a memory address in a buffer, where it is still inside your memory, inside your shared memory. And it's easily accessible from your backend process. So your client process, remember your client process, and Postmaster creates this backend process, and the backend process is writing to the shared buffer, not to the disk. So it's writing to the shared buffer and reading from the shared buffer. And if maybe this backend process wants to read some data that is not in the shared buffer, the shared buffer can request for that data, read that data from the disk, and saves it in the shared buffer. So that if that same request is made again, it can easily be gotten from the shared buffer. This works very similar to a cache, right? And that's what makes it very performant. That's what optimizes Postgres and makes it very fast and very efficient, right? And some people also go ahead to also add a cache in the mix of this kind of architecture, and that makes the application really. So you have some other processes like the while. So your while buffer and your while as well is your write ahead log. And what this does is when an operation is done on some file in your database, that operation before it is written, before it's saved, that operation is written to the while the while storage, right? So every operation performed on this database is saved somewhere. Okay. So if I read user table, that operation is saved inside my while, for instance. Okay. So if something happens to this database, if I need to recover the database, I just have to replay my while and everything is restored into the database. Okay. So that provides for resilience and data persistence of your operations, right? The writers basically write changes and modifications made to the files in your shared buffer to the disk. Okay. So if a change is made here, the writers help to ensure that that change is also reflected on the file inside the disk. And the checkpoints, there's something called dirty buffers. And this occurs when there are files in the shared buffer that are modified and that modification is not yet um, replicated inside the volume, inside the disk, in the data file that's in the disk. So the writers write those changes, and the checkpoints periodically check if what is in the shared buffer, the data, the state of the data in the shared buffer is the same as the state of the data in the disk. And this is how the processes work in Postgres. So if you want to try this out and find out more about it, you can easily set up Postgres in your Kubernetes cluster, deploy pgadmin, and you can interact with the Postgres environment. See some things on the memory management and the process management in Postgres. And you can also try it out in your application and see how performance improves. Um, so let me know if you have any questions on this or you want to find out more about Postgres or if you'll be using it in your application. And I'll see you in the next one.